All right. Well, maybe first about who I am. My name is Quentin Wach. I'm a physics student at the Technical University in Berlin. And as I explained as we were talking a few minutes ago, I've been working with a lot of data in the past few weeks, especially now that I'm back in the lab again. And what I see when I read a lot of papers in physics is that basically, while uncertainty is really highlighted, it's not very intuitive visualized. The basic idea in graphs in physics is, as I was explained, that you need to be able to reproduce the data from the graph in many cases, especially if you have a low number of data points. So I'm not talking about grand simulations where you're only showing a few nice pictures. But still, this is very important. So the main some of the main aspects of the discussion in any paper will be about how good is the data that was collected, and how does it relate to the model, and how can we how can we change the methods in order to improve on the data and hence get a better understanding of nature. But a different thing that you see is when you look at machine learning research, for example, is a different thing that I'm currently interested in because I want to switch after my undergrad studies. And I'm currently taking my first classes in computational neuroscience. And what you see is that uncertainty or the distribution of data is visualized quite differently. So while we have, I use the pointer right here, while often in physics graphs you have these little arrow bars with tiny caps on it, which can introduce some problems, especially for non-experts. In machine learning, when you have sample several points, so maybe you have a neural net and you train it on something, and then it's you have the accuracy of how well is it doing, basically, and then you're doing multiple runs on the same data set, but with different initial parameters, and then you can create a mean out of it. So it will be a smooth curve, which you can then use to discuss the underlying algorithm, and then you have a continuous confidence interval of where maybe 95% of the data should be found. While in physics, you're really trying to show often the raw data, and it seems like they don't really bother that much with creating beautiful graphs. Often you see papers and they basically using vanilla matplot, the vanilla matplotlib settings to show their data. So there are issues with it, and it's both affecting experts and non-experts. For example, when we look at these arrow bars, there's some people might confuse this not with a confidence interval, might not see this as a confidence interval, but confuse this with an interval in general. So they may think that the data can only be at maximum right here, and at minimum right just under the line. So that this is somehow equally distributed, or and not a normal distribution where you have 36% of all the or 86% of all the data in the largest area, and then with 2p and a greater and a greater confidence in larger when you do the error greater. Tough to explain it in English right now. But this is not exactly what I want to talk about. I want to talk about how we can do this better, especially in more popular media examples. So when we have elections, for example, or the coronavirus. For the coronavirus, for example, we always see these large growing curves of how many people are currently affected, and then there are often trend lines, predictions, several predictions for where it could go in the future. When we look at the densities, for example, here, this normal distribution, people are just really, really terrible at estimating areas. So I wouldn't think that this area right here, which I'm just circling around with the pointer, that this is 68%. And if you look at this visualization, which I took from another talk by Matthew Kay, who is a great researcher in this area regarding how to visualize uncertainty. It really doesn't look like this circle is equally large regarding in size of the area, like the circle that is surrounding it. But it's, you can take a screenshot maybe and figure it out. It really is true. Human psychology is really works different. We don't think in general distributions, and these arrow bars don't help much either. What we do is really we take one particular example and then we seek for the causes of this example, and then we build a more general idea of how the general distribution might look like. And so we are ourselves making approximations about reality, and we are actually doing from very little data, and we're actually doing this very, very well. So one thing Matthew Kay in one of his papers, and this is actually a theme in many other papers regarding this topic, you can actually improve this, improve how well people perform at estimating the probability densities, like here in the first, where I'm just with the pointer, by sampling a few dots to make a dot plot. So you can only take 20 dots, and because now you have discrete examples where people can count it, they're much better at estimating how likely it will be that when in this case, their bus will arrive. So about here, this would be if they are here after 6 minutes, for example, even though the mean tells us that the bus would only arrive at 10 minutes. If you're there at 6 minutes, you would have a likelihood of, or probability, that's the right word, that the bus will arrive, that you will be there in time of 95%. The strange thing is that if you use too many dots, if you make the distribution more continuous, like the density distribution here, that people get worse and worse at estimating this. Another thing which works quite well, though, is using a stripe plot, which really fits well into the frequentist mindset. So in this visualization, you really have a density in the true sense of the word. The lines get denser and denser, and this really allows people to make good judgments about the underlying distribution. Now, this idea of using discrete examples and not condensing everything into a single distribution, but using but actually showing the discrete points can help in several situations. This is an example of flight fatalities in 2017. And as you can see, every dot in this graph, and the graph is actually much, much larger. Here's a website you could maybe visit if you want to see the interactive graph, because behind this circle is a lot more dots. Every dot represents 100 departures, 100 flights. And if we zoom then into one dot, there's only 10 flights where there were fatalities. And this really is a much, much better better way of showing the relation than doing a curve, maybe, than just simply showing a distribution or showing people a number, maybe a bar chart of how many fatalities there are and how many flights or people there were that took these flights. Another example would be this popular article by, I think, the Wall Street Journal. And here again, instead of simply showing how different areas relate to each other, okay, here's a gimmick, here's a figure, but what really allows anyone to get a good feeling how the different parts of daily activities relate to each other in the amount of time is by that you can just count every little square and add them up, and just by the amount of time that you need to count the squares, you get a really, really good estimate for how much time it would take in the across the day, right? So this is another interactive example that you can open in your browser maybe afterwards. There you can create your own distribution, and we'll show you different visualizations of that distribution. And as I explained before, these dot distributions and strip charts really work the best by far. Histograms I often tried as well. They don't really, I mean, they look beautiful, but the resolution can be troubling, and oftentimes can give a false sense of certainty, as do density charts. And gradient charts is another problem in itself, as we are not only really bad at estimating areas and comparing them, but we are actually also really bad at seeing gradients and where they cut off. So estimating how the underlying density looks again. But one final thing I would like to highlight, which I didn't have really time to go into much more, was animation and simulation. Just like certain examples can help, or discretizing areas can help to help people to get a more general understanding. If you show them actually the data as it evolves over time in a simulation, which mimics what is happening, even though there are no numbers and there isn't really a clear showcase of the results, people still get a very good understanding of the statistics. In this case, what they tried to highlight, and which is highlighted by other simulations as well, because of this jitter and because of this movement that you have, is the uncertainty. In this case, this was at the election 2016 between Clinton and Trump. And the jitter was very strong at first as they counted the votes, and then got little and even tinier over time as the count got more, as the estimate got more precise. But this really somehow confused a lot of people who said it's random. It really shocked people because they didn't think that it would be possible that a needle could go right here into the red area, even though that the mean at the moment was somewhere here on the blue side. towards the Democrats. I think this is an example where it really showed how important uncertainty is. And I think that most people who saw this graph and got very shocked, they weren't shocked about the graph, they were really shocked about the uncertainty. And that even though that the numbers are currently maybe in their favor, if they're Democrats, it could still be, it was still likely that Trump would win, and he did. So this is what I got for now. Maybe we can, maybe we can somehow relate this to the general topics that you talked about here at the Interact. Thank you for listening.
Thank you.
Yeah, thanks for the presentation. That was really well done.
Thank you. One question I had regarding visualizing uncertainty and building on this, and maybe we can, and there's a lot more to be said, but which I didn't really have time to fit into this. If one visualizes graphs, for example, knowledge graphs, I imagine that some connections are less strong than others. Some facts are less certain than others. Less evidence for them. So I've read papers where they try to visualize the uncertainty in graphs and they try different things. They increase the opacity between the connections, or blur the connections, or use different colors for them. I wonder if anyone here ever tried something like this, or has thought about this in any way.
Yeah, so I'm working on 2 knowledge base editors and explorers, and this has come up a couple of times. I'm curious if that paper had any conclusion or any hints towards a preferred visualization method.
You mean regarding graph connections?
Yeah.
No, that particular paper that I read was more of an analysis how these different variables, visual variables, interact with each other.
Mm-hmm.
What seems to be clear is that that blurring is a really bad idea, because again, just like in one of the examples that I showed, if you show a blurred density, if you simply use color values to show a density distribution, then it becomes really hard for people to estimate the probabilities.
Mm-hmm. Yeah.
I think one thing that's important with the graphs are, just like every thing that you present or stories or whatever, or you author, is who is your audience? Because I think that really plays a big part on how you decide to design your graphs. So some people are more fluent in reading graphs than other people.
Yeah, yes, I would really add to that, because when you're a physics student, I used to be one too, and you know, physicists will write a scientific paper for other physicists to read. That's the audience. If you want to know about how people outside the world of science interpret scientific data, the place to start is probably a book by the name of How Charts Lie. Has anybody here read that?
Yeah, I have it here.
Oh, you have it there. Okay, you know that one already. But it's sort of required reading in this field. It's the Bible, and it's a lot of fun too. The guy is very good on Twitter.
There's definitely one
Hi,
book
Quentin.
on my list to read.
I'm gonna add it to. Sounds interesting. Hi, Quentin. Thanks for the talk. I wanted to briefly comment on what you said about knowledge graphs. I have, in fact, spent some time working on this problem of visualizing connections, but some time ago I was experimenting with some visualization libraries in JavaScript, such as Sigma.js and others. And even though I tried a few of them, I came to the realization that knowledge graphs should not be explored using visualization libraries. I guess some people would disagree, but for example, Aslan posted a question on Twitter a couple days ago saying, what would be a better way to explore highly or densely connected graphs? And if you don't have this problem at the beginning, that's okay. You can use visualization libraries in 2D or whatever. But once you go past a certain stage of connectedness, then you're going to come across this problem anyway. So at some point, like 1.5 years ago, I decided not to use visualization libraries for knowledge graphs. And that's what you have right now, for example, in Rome research, which looks pretty impressive at the beginning. But once you start adding nodes and connections, then it becomes useless, in my opinion. So I try to constrain myself to using one dimension, at most 2 dimensions. So what you have on Twitter, for example, is with the threads, you're just scrolling vertically, which is the easiest user interface today. And then if you want to go one level deeper, whatever topic you're interested in or tweet you're interested in, and you just click, and it's sort of a swipe to right or left, right? So it's in fact a really difficult problem you're posing, and even more difficult when you're thinking about different weights or fading connections depending on their importance. So the way that I would approach it is you have to take into account, another way to say audience would be what's the individual user exploring the knowledge graph. And that's the computational difficulty in that problem, because you have to keep in track all the places that this user has visited and all the preferences and all the topics that they're interested in, so that you can filter the number of connections that are adjacent to a specific node, and then provide a list of 5 or 10. No matter how complex your query is in Google, you are basically measuring the quality of the search results by the first 10 results. At most 3 pages, but I rarely go to the second one. So I would imagine a similar case for knowledge graphs in the future. The best platform is the one that is going to behave as a really good sorting engine and provide those 5 or 10 results for a specific use case, which would be the big difference with search engines, because in that case, you're just using a few data points like location or language. But in knowledge graphs, I think it would have to be more personalized.
Yeah, that's very interesting. That first part resonates really strongly with me, that if you're visualizing large and rich graphs with a lot of properties, then you have a couple of options, but plotting them all with a graph layout algorithm and trying to find what you're looking for is not one of them.
Exactly. I actually got scared by the layout algorithms because I didn't want to deal with that problem at the beginning. I was just like, okay, what's the most important connection? Not what's the best position for this node to be rendered on screen. 2 very different problems, both important, but yeah, I'm leaning towards the first one, as you mentioned.
You can also imagine it being as the world contains a lot of information. If you have all the information, if you have everything, then you have nothing. So it's the noise to signal ratio. The higher quality, the higher the noise to signal ratio you can get, the more qualitative your experience will be.
Yeah. So if I can quickly share my screen to just visualize this a little bit better. So I have this thing here, and this is quite a large connected graph, right? But when you're looking for something specific, you can do things like, all right, I'm only looking for children with this node. I don't care about the properties, and actually I want to explore from this one. So I can look at specific parts and how they connect to each other and explore locally instead of having this global and very cluttered image I had at the start.
Totally agree. Yep. You mentioned an interesting keyword, locally. I don't know if anyone has the same thoughts on that, but for me, that's the key. Every time you visit a node, you have something in mind about what you want to explore. Of course, you shouldn't be getting only what you have seen before, because one of the goals of knowledge graphs, in my opinion, would be to help us transition from text-based search to traversal-based discovery. So letting you find stuff without searching is something that we're not really good at today, even though we have some recommendation engines and stuff, of which I would say Netflix and Amazon are pretty good. But still, how do you bring that power to knowledge discovery and the overall learning process? So locality, you place yourself at a given node and then you explore from that point on. But if you see everything, as you see nothing. So that's the big trade-off of information overload.
Yeah, you're talking about intent, right?
Yeah, intent would be a way to think about it, especially if you're searching for something, and that's what search engines are trying to capture through the text query, right? But you would also have to accommodate for something different than intent, because as I said, it's pretty cool if you can find what you're looking for, but what if you don't, right? So I really like this scene in the Matrix movie in which Neo is being interviewed by the agent, and he's asking for the phone call, right? What if I give you the finger and you give him a phone call? And then the agent says, what useful is a phone call if you're unable to speak? So I have something similar for search engine. What good is a search engine if you do not know what to search? So in my opinion, knowledge graphs should solve that problem by, of course, letting you find what you're searching or looking for by estimating intent, but at the same time, let you discover things that you didn't know you were looking for until you find them.
Yeah, of course, when you have a hand-designed or a very organized graph like I just showed, you can just filter on a couple of edge properties. So you can see this as dimensions you want to explore in. But if you're working with a very heavily tagged graph or a hyper graph with a lot of different edge types, then this becomes very difficult, because even if you're filtering, well, no. So actually, filtering will work for a couple of use cases, but for other use cases, when the user isn't familiar with everything in the graph, you can do this filtering.
Yeah, you kind of need to know like what is available to be filtered, and if things are being filtered, like how much information is being reduced. Because it's interesting that you kind of bring up like searching. I like the Google analogy because, I mean, that's probably like the best graph that we have for knowledge is the web, and we have probably the poorest mechanisms for actually quote unquote searching that information. in my mind, the search is like an O of 1 type operation. I want to find one specific piece of information, and it should be really easy for me to get there. And it never is, right? It's not actually like the searching is more like browsing. Like, oh, I'll go to Google and I get like 5 million results, and maybe I have to click around to a couple pages. More often than not, though, I am just including filters within my Google search to kind of reduce that implicit graph that's created. You know, trying to find the local small piece of stuff that I can actually read through and pick apart to find the one thing that I'm actually searching for.
That's
I think
true. That's true. I agree.
One of the other things.
You're saying?
Sorry, what was that? I was going to say, one of the other things that I noticed was that, well, for example, in Quentin's talk, there's a lot of, like he basically focused on like uncertainty in the data. How can you visualize uncertainty? A lot of the data visualization talk at this event has been more along the lines of, well, like we're certain of the data because we're the ones creating the data, and then the question just becomes what best way can we visualize knowledge, for example, or what best way can we search through the knowledge graph. But I'm wondering if these two things are actually like more related than we think. Like, for example, if you're searching through somebody's knowledge graph, how can you be sure that the nodes in like that knowledge graph are actually like correct or factual, for example, right? Like, is there, if we think about the different like knowledge graphs that we've been talking about, do you guys think that there is any room for some kind of indication of uncertainty, both in terms of, well, I'm actually not sure that this node is correct or true,
Absolutely.
or on the other hand, like I'm not sure if there should be a connection between these two facts, for example, right? Like if you think about our own graph, if you're connecting two different pages, I mean, like I can think of some ways in which, like, well, it might not be a correct connection, or maybe there's some uncertainty as to whether these two things should be connected in the first place.
I mean,
Do you think that
imagine
makes sense at all?
if you look back at like the scientific consensus that was being formed around the coronavirus around March, that would have been like the perfect use case, because so many people were trying to make discoveries about what the hell is going on. But you know, that discourse is alive, and so when somebody makes a hypothesis that, you know, oh, you know, maybe it's not necessarily a respiratory disease, maybe it's more blood related, because that was one of the ideas that was starting to gain traction. You know, the public doesn't necessarily know how to digest that as being uncertain. It came from science, therefore it is science. I have to trust that. But the
Yes,
scientists
believe
know,
in
like,
science.
we're talking about it still. The science is the process of understanding, not the dogma of it.
Yeah, and I think that connects very closely to the problem with having a confidence value or a truth value for anything, in the sense that there is no truth, there is just evidence and counter evidence, and that it, like OpenCog, for example, they have this machine learning system based on knowledge graphs, and they tried to have a confidence value and a probability for every edge, and use this in learning. But this worked well on small scale, but when they scaled it up and they went to customers, they noticed that what is the certainty is except for domain-specific things, very uncertain. And that often better guesses can be made by looking at the evidence instead of looking at trying to put a number on it and trying to filter on it, trying to select from it. No, you look at the evidence, and if you are an expert, you can filter on that evidence, and you may have an idea of what are the prominent researchers. You may have an idea of what are the what are the ideas that make most sense, but you don't have an idea of truth, and that's okay. I don't think that needs to be embedded in any kind of knowledge graph.
So we need.
That goes back to the audience, though, right? So I think if your audience are scientists, then they believe in the evidence. But if you talk about the general public, then a lot of times they don't believe that because their leader says it's not true.
But having
Can't
evidence
have to.
for something doesn't mean that that thing is true.
Exactly.
Right? So
You need to
I
be
guess
able
we
to
need some way to visualize different hypotheses, different possibilities.
right, like the
with
weight
different
the
likelihoods.
weight of all evidence connected to a particular conclusion or assumption should be, calculated. So if you have some conclusion about, coronavirus, you can see all of the supporting claims, and then you can also see all of the what's the antonym for that? Non-supporting claims, right? Everything that goes against that conclusion to say that no, this is false.
Yeah, there was a team of guys I talked to a while back in Israel, and they made this platform called Root Claim. And basically what it was is it would take a question, and then it would look at the different hypotheses for what the answer to the question could be. So for example, there was one of them was like a plane crash, and then they were looking at different hypotheses for why did the plane crash. And so what they would do is they would collect a bunch of evidence, and then have a list of hypotheses that is basically like exhaustive and mutually exclusive. So, like you'd have like hypothesis 1, hypothesis 2, hypothesis 3, and then something else that's not hypothesis 1, 2, or 3, and then you would assign likelihoods to all of those based on the evidence. And like they have a detailed explanation for how they do it on their site. It was nothing related to like some kind of visual representation of graphs. They just had a page that would list all of these things out, but on the back end they basically used like a Bayesian network, and they would like weight certain evidence as more or less credible, and then they would run that through and generate probability distributions for like which hypothesis was more likely. So maybe there's something that we can learn from their site as well.
Did they store those weights in the graph itself, or was that metadata on top of it?
How do you mean? Like I'm not quite sure how they stored that data in the back end, but like what they basically did was they had a bunch of evidence for the different hypotheses. They weighted that evidence, and like in terms of like how credible the source was, how etc. Right, and then they basically just used like a Bayes network to integrate in all all of the evidence into one hypothesis. So they get like a likelihood or like a weight for that hypothesis, if that makes sense.
Yeah, got it. It was probably just the outcome of the process, but it was never stored back into the model, I guess.
I don't think so, although I don't quite remember. This has been a while since I looked at their stuff. I can post a link to it in the description though. or like in the links channel.
Sounds
I
good.
think
Yeah.
there.
Thanks.
Go ahead.
It's starting to feel like a local area network. Everyone waiting to avoid collisions. I was not going to say anything. Sorry about that.
So what I'm thinking about this is that you still have the numbers, and although using base rules and propagating these probabilities through the network sounds clever, you still have these truth values which at some leaf or at some point you have to define. And even when you have a decentralized network, there is this can be very misleading or very untruthful to have credibility numbers that propagate to the weights of edges. One other suggestion, no, I'm not saying this is the way to go, absolutely not, but if you're only working with solid properties, not with floating points that should represent some truth, then you could, for example, look at someone you do believe, like in a representative democracy, and look what they believe, or look what others believe, and this can be very accessible, and in some way is more honest than putting a truth value on it.
Does anyone have any questions for Quentin about the stuff that he talked about?
Let me see. Have you seen any other visualization graph representation? I'm thinking about making a graph representation where you're able to fold in different subgraphs. So let me see. I don't want any edges to overlap as most as possible, but I also want to be able to focus in on locality. So I want to focus on one specific node and then have all the main nodes around that become larger. And then, but if you navigate one of those, they might have a lot of tiny subnodes as well. So depending on where you're standing, the graph will, it's multidimensional. You'll see everything from that perspective where you're standing. Do you have any examples of that? Or did I make sense or not?
I'm trying to relate this to uncertainty right now. What I got from your explanation right now is that you're really just trying to zoom in certain areas, right, of the graph?
This was more to a previous topic about being able to visualize large graphs and having it with detail, but still.
Yeah, I mean, there are different ways. In Rome research, I don't use Rome research, so my knowledge is limited. But I think the connections are just linear lines, right? In these graphs, I'm using Obsidian, and at least there, this is the case. I know that it is definitely possible to use lines which basically bond together like strings made of several lives. So it looks like more. So you can see clusters form basically. But
may I show?
Do you have something?
Maybe. Or I'm working towards something. Are you able to see the screen?
Yep, you can see your screen.
Okay, so this was just something random that I tried to. So the idea would be that you can center yourself around one specific node. Here, for instance. And then the nodes just around you will be bigger, or the important nodes from your perspective will be bigger. But the smaller node, then they have subnodes, and they have subnodes as well. They have neighbors, and they have neighbors. So the neighbors might be very hard to fit into a two-dimensional plane. But if you then scale down the subgraph and make it very, very tiny, you will possibly be able to fit everything there. And then if you try to navigate towards that node, then everything will warp around you and change it so that everything just around you will become bigger, and the thing that you were on previously will become smaller again.
What
So it's
you're
almost like
describing
you're
sounds
like
very
walking
similar
around
to. Oh, go ahead.
I was gonna
Feels
say,
like a third dimension.
Exactly, yeah. Like you're adding dimensionality by just like scaling different nodes. It's almost like it almost reminds me like if you're walking around in like a hyperbolic space, for example.
Yeah, that's what I was going to mention. It's like a non-Euclidean geometry almost.
Yeah, that's the idea. Do you have any examples of this, or seen anything like this before?
I don't think so. No.
Not with graphs, but there is a guy on YouTube actually building a non-Euclidean game engine right now.
Yeah, there's several, I think.
So with graphs, there is this concept in machine learning where we try to embed words in a vector space, and in a way, words correlate to each other more in a graph way than in a vector way. And there has been some research, and this is become very prominent, where they look at graph-based or even non-Euclidean metrics of distance instead of to accentuate this local cohesion. So one example may be that they use the hyperbolic metric for distance when training this network on word embeddings, because that's closer to the graph nature than the Euclidean metric.
It would be very nice to see example links. I would be very, very happy to see that. Also, Bopa. No, go ahead.
Yeah. No, I was just trying to think how to bring the conversation closer from just general graph visualization to the central topic of the talk about uncertainty. And Quentin, you mentioned something about connection fading or blurring depending on the weight. One way that I think about that in terms of trails, which I mentioned in the hypertext session, and specifically by recommending this book called On Trail by Robert Moore. There are a few stories there very interesting taken from nature. For example, ants using pheromones, I think, to indicate that they're stood in a particular direction, and the different levels of intensity in those trails depending on how many ants pass through that and laid the specific chemicals. So that at the beginning, I was trying, maybe I'm forcing it too much, but I was trying to think about scientific research in the same terms. And then some scientists are looking for the low road less traveled. Some scientists are going down a path that has never been walked before. And then you have a body of researchers following a particular trail behind the leading researcher and trying to give support to their claims. So I don't know if that would fit your model, and thinking at the beginning you have some connections or trails that are not as strong as the other ones, but then as more researchers go through them and give weight to those connections by traversing them, then it would start forming a path for other people to continue to research. Is that closer to what you meant by weight or not?
So, you're talking to me right now?
Yes, sir.
Yeah. Yeah, you were kind of hard to understand at times, for me at least, just because of the transmission. On Trails is definitely a book I want to read soon. I think the idea of evaluating the strength of the connections between nodes is, especially when you look at, I personally look a lot at citation graphs and think about how you could build more understandable citation graphs, simply because I personally have a lot of interest in that problem. And it would be certainly interesting to simply look at what you just talked about, how many researchers are walking down these paths, to then evaluate how important maybe that research is. I think this is already done in many ways. I mean, you can do it through citations in this case, which is the obvious route, but also simply on clicks. How often has it been read by others? There are a lot of popular articles which are cited very poorly, and a lot of popular articles which are cited very highly. So you can draw conclusions from that as well.
Yeah, you made me think about mentioning making a citation in a scientific article currently has no way of conveying the weight unless I'm missing something. I mean, the only indicator is maybe the order in which it's cited, like first in the list or down the bottom.
I've been talking with Seth about this, or mentioning it to Seth a few weeks ago. There are algorithms, I don't know the name right now, I can maybe find it later and put it in here, where because it's ordered in time, you can actually track back what the exact paths which led to that particular research article. So you can really somehow evaluate very well what articles were the most important for one particular article and which articles were most important for that article, considering the article that came before. And then you can really put together a story, or you can really see a long trail leading back to one original paper, maybe. But this, how exactly this works, I have no idea.
Yeah, that's pretty cool. I'd love to see that link.
Like one.
It's basically, it's definitely, yeah. Sorry.
I was just gonna say, like, one problem that you'd have to solve there is, like, how do you trace back the citations? Because, for example, if you're reading a paper and you go to one of the papers cited in your original paper, that paper is also going to have a bunch of citations, and so if you're trying to trace an idea back to its origin from backwards, then how do you know which citation to then go to, and how do you know how to Jorge's point, like how much does each citation contribute to the actual paper?
Yeah, I think you can. I mean, it's.
I don't know how to solve that.
I know. Well, I mean, it's not like papers are simply. It's not like there are simply references at the end of a paper. There are most research. There's always somewhat of a summary of the research that came before and that inspired the paper. And when you get into more technical details, then we will see references inside the text where they point to a key idea from a paper. So maybe it wouldn't, and we talked about this as well, maybe it wouldn't make that much sense to only look at the papers, but more at the ideas inside the papers and build a graph from that. But I think that's more science fiction than science.
I think we could be getting close. I know NLP in like the legal space is starting to get big pretty fast, because there's tons of legislation in every single country, and they're all unique. It would be really nice to be able to make legal decisions based on all of that information more or less instantaneously, instead of having to have the whole legal team read through, historical rulings or whatever. And I think we'll be getting closer to where we could do that with scientific literature as well. If we were able to create an argument map of the science and actually show, semantically, here's the hypothesis, our experiments, several conclusions, any sort of referential link to previous work then becomes inexplicably, well, not really, it is explainable. It becomes tied to the research directly. So if you have a claim which is like, yeah, see, this claim works because of this result in this experiment and the results of all of these past experiments, then you at least have the graph to say, well, okay, if the past experiments fail, based on new research, then what other science needs to be reevaluated.
It might actually be easier to do this to decouple. Also, if it was possible to do this, to get the arguments from a paper, to extract it somehow, that you have the premises and then the evidence, and then you have this logical structure that leads up to the conclusion of the paper. Then you could combine this and cross-reference it with other papers which maybe came to the same conclusion, but for different reasons, and add this together to create a more complex graph and maybe increase the certainty that this is actually true, this particular conclusion. I think this might be easier than. I mean, if you're already analyzing how much references contribute to a paper, then you need to do this anyway. So.
Right, like you might not have the NLP algorithms like really tuned enough to do full argument extraction, but that is part of the research, right? Is finding what is applicable. So I mean, you can manually tag all of your research.
I mean, why not? Why can't humans do that? Why can't humans just do this collaboratively?
Exactly.
Right, like really, we should have a better interchange format for science, which is not the PDF. The PDF is not really good for extracting information out of things.
Totally.
Please tweet it.
I mean, you could also have some kind of like you could split the work between some kind of AI algorithm and humans, right? So for example, if you're writing a paper, maybe you would highlight like different ideas in there or different arguments, and then you'd reference those highlights to like specific citations, or at least get started on that, and then like train the AI to basically either process that data or like to then like be able to better recognize like
Yeah,
how
you-
the citations relate to the different ideas in articles. And
You'd be able to
maybe
have a
over time automate
dialogue
them.
with
Yeah.
like the AI. You could say, "Oh yeah, I think this is an argument that supports this," and the AI could be like, "Yeah, I agree." And the AI could be like, "Oh, I think this is a contention to this other argument," and then you might look at it and be like, "No, that's a question. Are you crazy?"
Yeah,
If you had something like a
sorry, go ahead.
This is actually an active area of research within the AI safety side of things. If you want to look into this, it's called debates in AI. And it's a game theoretic concept where you have two versions of the same agents that you and one has to take in the pro position and one has to take in the contra position. And they built this tree of argumentation where they try to recursively break down the previous argument until the chunks are small enough they are indisputably right or wrong. And this can be used in two ways. This can be used either, or in actually more ways than that, but this can be used to to explore what parts of a question has, and this can be used to hint at the truth behind it. So if you actually let this play out, then and trust the AI system, you can see the truth. But otherwise, it's still a nice exploration of the topic.
I'm a bit astonished right now. Do you have a keyword? So I can search for it?
I will share the link.
Okay. I know that there were experiments where agents communicated, and but I never. I don't know what you mean by an argument in that sense. You mean really talk to each other, or?
Yeah. So there are different languages used at the moment. Well, one of the languages is very simple. For example, when you're argumenting based on evidence of a few pixels, if it's a picture of a cat or a dog, then an argument may look like both an argument and a counter argument may look like revealing another pixel, right? And this can be seen as bringing another piece of evidence. So if the one agent thinks it's a cat and it reveals a pixel where you would expect the pointy ears to be, and there is nothing, then the other AI can say, look, here you would expect fluffy ears to be, and when the AI reveals that information, you can see, oh, all right, he's right. And so they can either figure out if it's a cat or a dog by recursively applying this, or they can help you explore this very difficult topic. Well, for us it's not, but it could be very difficult topic with the highlighting that the AI systems propose.
It sounds interesting. I have to read that paper. That was Poincar embeddings for learning hierarchical representations, or I saw that.
No. Yeah, so that was about the graph. So the graph and the word embeddings. But what I'm talking about now is debate in AI, and I'm actually searching for the OA. I think it was Christian who put this out, but I don't know. The AI safety space is quite connected, so to say. It's not very large yet, but it is very interesting.
would definitely love to get back to the idea of extracting arguments, building argument networks in some, maybe one could call it like that, from papers. More or less automatic, but automatically would be the idea, but ideal. But I think that there can be a lot done just using the collaborative power of scientists. So if you had something like a special PDF viewer, where like Seth explained before, you could mark certain passages and link them to the references. Basically, what's already done inside the paper by the author, and construct arguments to build a map for yourself, maybe in order to remember it better and understand it better. Then you could see, look at other researchers, look what are they doing? Are they all doing the same? Basically, are they constructing the same arguments? Are they taking away the same thing from one particular paper? And then you could maybe create a solid argument structure from this without the use of machine learning. I see you have posted the paper. Thank you.
I really like what Ron had to say about the better exchange format for scientific research than the PDF, because you could imagine that it would be a matter of maybe defining a language or something like that, and researchers themselves, not NLP models or anything like that, but researchers themselves would, on top of writing the abstract and maybe a short form article or something, they would just provide this structure mapping the dependency graph or the connections between arguments and the explicit steps that they're contributing to. I don't know if that would be graphically drawing a graph or something more text-based or what, but yeah, I really like that idea. I'm going to ask you later about it, Karma.
It would be also really interesting to be able to like link relevant experiments back to something that's already been done, right? Like if there's been a paper which explores a certain idea and they use a number of experiments to kind of back up their claim, it would be interesting, if 10 years later you could just continue to build off of that one paper by supplying more experiments without having to try and like republish another paper. Although, you'd probably have other things you'd want to say if you discover that the last paper was maybe like p-hacking everything. But to be able to like directly link to other papers to fix contradictions, like especially in the field of psychology, which is like yeah, nothing else to say about that, but I think that would be really valuable.
It's almost like a GitHub for
I would even
papers.
push it further. Go ahead.
Talking like a GitHub for scientific papers.
Yeah.
More like a blockchain for scientific papers, if you ask me.
Git chain, block hub.
yeah, sort of. Yeah, I was going to say that maybe you can even push it further and try to remove the word paper from it. I also mentioned a couple days ago that we are trapped in the paper-based metaphor, and that's not only for the web. I mean, it's funny that we're still speaking about PDFs and papers in science, when the real important part is the argument and the contribution, which doesn't need to be living in a PDF. This year, David Graeber, one of my favorite academics, passed away, and he was working on many topics, debt and the economy and whatever. And he had a tweet about LibGen, Library Genesis, like sarcastically complaining about people that are complaining about users uploading scientific papers to Library Genesis. Something like, why would you want people to be able to download your research? That would advance human knowledge or something like that. So if you think about the PDF not being the best format, it's also holding us back by punishing collaboration and sharing. So I would love to see a better format, both for charting the graph of arguments and also to make it easier to both share and to reference that making links.
Yeah, at the very least, I'd love to have some forward references with research. Like, I've been trying to get into natural language processing by reading papers, and it's so hard to know, like, what's relevant or where to go next, because you read a paper and you can see the trail of research behind you to read. But you just have to kind of like be constantly watching Arxiv to find new research, which may or may not be connected to the things that you're actually interested in, which is
Follow
so
some
frustrating.
prominent researchers on Twitter. Helps a lot.
I need to find more.
Yeah, or just ask the researcher that wrote that particular paper. Or there is always there. I mean, there are tools like connectedpapers.com. I'm using that quite frequently right now, and that really that's creating a graph which recommends you related papers, not just backwards in time, but also paper that built on that.
Oh, what did you say it was?
Connectedpapers.com. I can send the link in a moment. Okay.
Oh, heck yeah, that is going to be so nice.
And I think Academic Microsoft is doing the same. It's another tool I like. So there you actually have a dedicated section which the most important papers, then the most important papers for this paper which were referenced, and then a third section where papers are highlighted which build on that article. And they say that they're using a semantic graph.
But doesn't everyone say that?
Yeah.
Just like every startup is machine learning powered. Or excuse me, AI powered.
I mean, I found it useful. I still find it useful. But it's limited, of course.
What do you think the biggest limitations still are?
I think it seems to me actually that most people are not really trying to solve the problems that I feel have to be solved. So when we talked about argument extraction, I don't think that Microsoft Academic is doing that, for example. I think what they're doing is really just looking at keywords and then trying to map that to a certain category. And they're looking at the references and and citations and stuff. But it would be nice if there was actually natural language processing algorithm which would extract arguments, but or somehow it doesn't even have to be arguments that have to be extracted, but just summarize a few sections. That would be nice. I think there has been a paper. I read a paper a few weeks ago where they actually did that, where they actually summarized whole articles in order to make it more easy to find new ones.
Yeah, I recall seeing a paper like that. The abstract was pretty cool because it basically kind of outlined, the abstract was an abstract. It was like, yeah, in this paper we provide a blah 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 which does these types of things using a natural language processing, and this entire abstract was written by the tool that we created. So it's like they just wrote the entire paper and then let the machine write the abstract for the paper that describes itself.
So this is one first step, and I would love to see more work in that direction.
I've used GPT-3 a couple of times to summarize my, not summarize, sorry, write a conclusion for my research articles.
Yeah, I tried similar stuff as well, but I didn't go through with it.
It's definitely good for a starting point, though, because you could at least read the AI conclusion, and if you take offense to any of it, then you know exactly what to change at that point.
Yeah, I mean, these collaborative interactions with artificial intelligence can be. I think this will be very, very useful in the future. Right now, I'm using so it's called Grammarly. I mean, I've seen so much ads about it, and at some point I installed it, and it really feels like you're interacting with it because it makes so many. You have to really adapt to it, and it helps for someone who I speak German most of the time, so it really helps me to improve my writing.
Yeah, I've actually been using it as well. I almost exclusively write in a passive voice. Grammarly is always there to shout at me for for doing that, so that I fix it.
Yeah, it's shouting at me for that as well, but I don't really get it.
Oh yeah, it's so confusing.
I mean, I'm being told every day in university to write in a passive voice, but when I read academic articles from the US or some other parts of the world, I mean, they're using. Am I misunderstanding something, or I see often that they're writing from a personal perspective and not passive. Maybe I'm understanding the whole thing wrong.
That's correct.
Yeah, I feel like usually I'm told that I need to write in the active voice, but I don't really know the difference still. I've tried to teach myself the difference between active and passive voice, but unfortunately, English is not my strong suit, and it's the only language I know.
Weird. So maybe it's a German thing. So to write I or we or something like that in our articles is completely forbidden.
Oh, interesting. Yeah, that's completely different from English papers then, because it's always like we propose blah blah blah
Yeah.
blah blah to do.
Yeah, I had this debate over and over again with
That-
my tutors and professors. There seems to be a cultural difference in how to write a paper.
I really like that, honestly, because I mean, well, maybe. I think a lot from what I've seen in research, there's definitely like this massive popularity thing going on, right? Like there are like the certain metrics that show how good of a researcher you are based on your paper output and how many times your paper is linked to other papers, which
Yeah.
I think is really destroying what actual academics are trying to build. People are just hacking that mini paper game.
Mhm.
I don't know, maybe the language feeds into that popularity thing, maybe it doesn't at all. That's really interesting though.
I mean, that somewhat also relates to what I talked about in the presentation about graphs, where the standards and values are very different. Where in physics you really want to highlight the precision of your data, where you draw you show the uncertainty, but you really wanted to have. Basically, any other physicist should be able to take a ruler and be able to write down the exact numbers of the data points. And in other research fields, the data is completely hidden behind a weird line, and very colorful and modern in design. I wonder why this isn't really talked about. I wonder. There should be somewhat of a style guide for every research area, what is expected. But yeah, it's getting late where I am, so I gotta go now, sadly. But I enjoyed your company very much.
Yeah,
And I
thank
hope
you. Thank you for the
Same here.
presentation.
Thanks a lot. No worries.